Measures of dispersion. We know that the measures of dispersion are standard deviation, variance, the age, the mean deviation, skewness, among others. And the first example we want to look at is ungrouped data. We have been given the weight of 10 students. And we want to use that to be able to do the computations that follows. So we have been given a number of activities to take here. One of them is the range. And the range is you take the highest x maximum minus the lowest value of x. And when you look at that data, the highest value is 68 and the lowest value is 44. And that gives us a range of 24. So the range is from the highest and the lowest. The second one is what would need to get is what we call the standard deviation or the mean deviation. So if I was to get the standard deviation, all I call SD, we need to get the mean, and we are going to calculate the mean so that we know how to calculate the standard deviation. The mean is given by x bar, which is the sum of x over n, and that means you sum all those values that you have there. And if you do that mathematics of summing all these values, starting with 45 followed by 68 all the way to 44, and then you divide by 10, it will be giving us 530 divided by 10, and therefore we have a mean of 53. Now the question is, why do we need the mean when we are calculating the standard deviation? That is based on the formula for the standard deviation. The standard deviation is given by the summation of x minus x bar squared divided by n minus 1. Why are we dividing we use n minus 1 if n is less than or equals to 30. And since our n is 10 students, then this is the formula. So how does this work? We take each one of the values and then we square. We sum it. So the first value that we have is 45. So it's 45 minus 53 squared. You get the value. And then we have 68 minus 53 squared. And then the list goes on. We get the third one, which is 52 minus 53 squared. So our values will be positive because of the squaring of them. And then we have 50. Then we have 59 minus 53 squared, and then 55 minus 53 squared, and then finally we have the last two values, which will give me 50 minus 53 squared plus 44 minus 53 squared. And so 45 minus 53 is 8. This is 64 plus 13. Not 13, it's 15. 68 minus 53 is 15 squared is 225 plus 1 plus 16 plus 9 plus 25 plus 36 plus 4 plus 9 and plus 81. And if we do all that summation together, this will be equals to 470. The standard deviation is given by 470 divided by 10 minus 1, and then we get the square root, which is 470 divided by 9, the square root of that, and the standard deviation is 7.2265. So those are the deviations that we move away from the mean value. And then the variance is the standard deviation squared, so which will be 7.2265 squared, and that will give us the variance for that problem that we have. And finally, we have what we call the mean deviation, which is given by summation of x minus x bar divided by n. So we are getting the absolute value of each one of them. So summation of x minus x bar will be equals to the absolute value of 45 minus 53 plus 68 minus 53 plus 52 minus 53 plus 49 minus 53 plus 50 minus 53 plus 58 minus 53 plus 59 minus 53 plus 55 minus 53 plus 50 minus 53, then plus 44 minus 53. So this is equals to 8. That is 45 minus 53 is negative 8. The absolute value of negative 8 is positive 8. 68 minus 53 is 15. Then 52 minus 53 is negative 1. The absolute value is positive. 49 minus 53 is 4. Negative. Absolute is positive. 50 minus 53 is negative 3. Absolute is positive. 58 minus 53 is 5. 59 minus 53 is 6. 55 minus 53 is 2. Negative 3. Then absolute is positive. This is negative 9. Absolute is positive. So those are the values we have. And this gives us 56, and therefore since we have 56, then the mean deviation should be equals 56 divided by 10, which is 5.6. So that is how we get the measures of dispersion for ungrouped data. For the second part, we want to look at grouped data. We have an example of 50 adults cholesterol levels that was measured and it was tabulated below. For those who had the cholesterol level between 120 and 129, there are 4 adults. 130 to 139, there are 6. 140 to 149, there are 17. 150 to 159, there are 13. And 160 to 169, there are 10. We are told to calculate the standard deviation, the variance, and the mean deviation for the data. So the first step is to itemize the formulas that we are going to use. For the mean deviation, it is given by the summation of frequency x minus x bar divided by n, and for the standard deviation, it is equals to summation of f x minus x bar squared divided by n, and then we get the square root of those values. So that is what we want to get the formulas. Remember that we say that the mean deviation is given by summation of f x minus x bar divided by n. So the first thing is I need to get the midpoint, which is what we call x, and this is 124.5. How did I get 124.5? Is 120 plus 129 divided by 2. 130 plus 139 divided by 2 is 134.5. And then we have 144.5, 154.5, and then we have 164.5. The other thing I'll require is the x bar, which is the mean. So I need to get f times x. I'll multiply f times x. That is, f times x is 498, 807, 2456.5. That is 17 times 1, 44.5. And then 13 times 1, 54.5 is 2008.5. And then that is 1645. And then we have 7415, and therefore our mean is 7415 divided by 50, and that will give us 148.3. That is important for us to be able to get the mean deviation, which is f x minus x bar absolute value. And how do we do that? We take the x value 124.5, we minus 128.3, we make it absolute, means if it's positive, negative, we make it positive, and then we multiply by f, and if we do that, we'll get 95. So basically, we are multiplying 4 times the absolute value of 124.5 minus 148.3, and that will give us 95.2. The next value, the frequency is 6. I get the absolute value of 134.5 minus 148.3, and the absolute value of that times 6, it will give me 82.3. The third one will be 17, then it will be 144.5 minus 148.3. I get the absolute value, and then I multiply by 17, and that will give me 64.6. Then the fourth one will be 154.5 minus 148.3 times 13 will be 80.6. And then finally, the third one is 10. 164.5 minus 148.3, and the value will be 162. So if I sum all this, it will be 485.2, and that will give me the value. Now with that value, then it's very easy for me to compute the mean deviation. The mean deviation will be given by 485.2, then I will divide through by 50, and the answer will be 9.704, and that is the mean deviation. Now the last step is to calculate the standard deviation, and we have our classes here that you have been dealing with, and I want to rewrite them again so that we are able to follow through. 130 to 139, 140 to 149, 150 to 159, and then 160 to 169. We have the frequencies as 4, 6, 17, 13, and 10, and the midpoint we have is 124.5, 134.5, then we have 144.5, and 164.5. Remember, for this it is fx minus x bar squared, so this is 4, 124.5 minus 148.3 squared, and that will give me 2265.76. The second value, it is 6, 134.5 minus 148.3, you square, and that will give me 1142.64. The third one is 17, 144.5 minus 148.3, you square, and that will give me 245.48. And then the other one will be 13, 154.5 minus 148.3, you square, and that will give me 499.72. And the final one will be 10, 164.5 minus 148.3 squared. So it's 164.5 minus 1.8.3, 148.3, you square the answer, and then you multiply with 10, and that will give you 2624.4. If you sum this gives you 6778 as the final value of the summation. So that is the sum after you sum them up. And so what does that mean? It basically means then that the standard deviation is equals to 6778 divided by 50, and the square root of that will give me 11.643. What about the variance? The variance is equals to standard deviation squared, which is 11.643 squared, and that will give me 135.56. So that is how you compute the mean deviation, the standard deviation, and the variance of grouped data. I'm sure you are loving the videos. please do subscribe.